finally, we're going to solve some differential equations today. Yay. Whether you look at it as a good or a bad thing, you've already kind of learned this method, but we're going to review it anyway.
Chase.
Okay, so today we're going to talk about separation of variables. And we start with the idea that if g of x is a continuous function, then the differential equation dy dx equals g of x can be solved by integration. If you move the dx over to the other side, and integrate both sides, you get a solution. Y equals, we'll call this capital G of x, plus some constant of integration. There's a constant on both sides, obviously, but we just need it in one spot, because we can combine the constants. Okay? And clearly here, capital G of x is the antiderivative of little g of x. Okay? So let's do an example. Let's say dy dx equals secant x times tangent x minus sine squared x. First you multiply by dx. And then you so the answer is secant x. That's the antiderivative of secant tangent, right? Maybe we should think of sine squared x as 1/2 minus 1/2 cosine 2x, if it helps. So what's the answer then?
Minus 1/2 x.
Minus 1/2 x.
Minus 1/4. Or plus 1.
Plus 1/4 sine 2x plus, no, negative times negative is positive. Antiderivative of sine is cos. Okay. Plus constant. Yay, we solved the differential equation. Well, there's some more interesting stuff we're going to do. Okay? Okay. So this up here, let's call this equation 1.
Which one?
dy dx equals g of x. And now I'm going to say that 1 is just a particular case of this bad boy.
Bad boy. I almost wrote it.
Nothing's stopping you. So now we have maybe not only g of x, but potentially a fraction or something. The idea is that you can separate. Yep. So if you separate the variables, you have h of y dy equals g of x dx. And then you integrate both sides. And go from there.
Can you just have a constant on one side?
Yes. So maybe h of y equals g of x plus c. Again, capital mean antiderivatives. Okay, now, this means potentially two things. One, we may not be able to find a nice explicit solution for y, and that might be okay. Other times, if you can easily isolate y, so that we can say, well, here's a solution, y equals this, then we go ahead and do it. Okay? Here's the next example. Let's say dy dx equals x minus 2 over y squared. The next step should look like
integral of y squared dy equals integral of x minus 2 dx. Right?
Mm-hmm. So separate variables, get all the y's on one side, all the x's on the other, integrate, and now we get 1/3 y to the third equals
1/2 x squared minus 2x.
not an explicit solution, but easy to find one. Right? What would y be? Well, let's do C. Let's call this C1. And let's call this guy C2, where C2 is what?
3 times.
Yep. I do expect you, if you have constants that become new constants, somehow to explain where that's coming from. Okay? You could call this C and C1 or C1, C2, and if there's more manipulation, we get a C3, that's fine.
So we have to define it though. C2 equals.
Yeah, because if I'm following your solution, I want to know because if you left it as C and C, that's clearly not the same constant, right? You could have left it as maybe 3C and kept the constant the same. That would be okay. It is, but
What you're saying is a specific arbitrary constant.
because if we're solving an IVP, it's actually not arbitrary at all, right? Because that constant needs to be determined. But if we don't have an initial condition given, then yeah, these represent an infinite amount of solutions. Okay. Next. Why don't you guys try this one? So dy dx equals 2x over 1 plus 2y. Bless you.
That's good.
So now we have an initial condition given. Go ahead and find the solution. Give you 90 seconds, and then I'll go through my answer.
If you plug in 2 for all the x's, 0 for all the y's, c for the score. Did you get that? You did? Put 0 equals 4%. Oh, probably. I think you just hit the I don't know. It's close.
Does anybody have it yet?
What do you want?
The final solution.
The equation.
So you want us
Let's do solve for it.
So y equals,
So does y have to be isolated?
yes.
I don't know how to do that.
Isn't there a square plus or minus the square root
Oh, you
of
don't
x
have to put it
squared
in
minus
minus.
15 fourths? And then outside the square root minus 1 half.
Almost. You don't need the plus or minus, actually. Because if the root is negative, it actually will not go through the point. Does that make sense? So, that's good. Final solution,
But how do you solve for y in
you
this?
can complete the square.
Well, that's good.
Would you like to just go through that? Because I suck at.
Completing the square? Sure. So dy, whoops, I don't know why I put it so far. 1 plus 2y times dy equals 2x dx. That's y plus y squared equals x squared plus c1. I'm going to complete the square on the y's. So y squared plus y plus,
Well, why would you do it now?
because I want to find what y is. I guess it doesn't matter when you do it. I just like to do it now. Complete the square, you need half of 1, which is a half squared, so a quarter, right? Equals x squared plus, I'll call it c2, where c2 is a fourth plus c1.
Oh, I see.
And then now this factors as y plus 1 half squared.
So you just have to add 1 quarter to all the.
Mm-hmm.
What's negative?
Equals x squared plus c2. Take the square root. You get plus or minus the square root of x squared plus c2, and then you'd have to subtract the 1 half. So this is what I have as the solution, but now since y of 2 is 0, you can remove, this is what we were saying earlier, we can remove this case, because a negative minus a half is never going to give us a y value of 0. Okay, so we toss that out. So then to find our constant, we just plug in 0 for y, plug in 2 for x. So we're going to add a half, we square it, subtract 4, so 16 fourths minus, subtracted from 1 fourth is negative 15 fourths. So that's the C2 value. So that tells us that the general, or the solution to the IVP is the square root of x squared minus 15/4 minus 1/2.
Why didn't you just plug the numbers in the very beginning?
Where?
Like, once you, right after you
Right here?
created it, yeah.
You can.
I think it's
Okay.
Doesn't matter.
Like, can we just, once you do that, can you just leave that as,
I mean, you're still going to get the same.
okay, you gotta get to this point?
Yes.
Okay.
So it doesn't matter where you find the constant. If you carry that constant through from the beginning and then solve for it later, or if you find it back here, I mean, you're still going to get the same
Okay.
value. Okay. Let's try this one. Beef it up a little bit. It is.
Yeah.
So, in a matter of a couple days, you're going to look at this equation, and you're going to start to go through this like process or a roadmap and try to identify, well, is this going to be separable? Is this going to be homogeneous? Is this exact? Those are the only three that we have left before the exam. Right now, since all we've talked about is separation variables, right? That means that there must be a way to separate variables here. Okay? So, first, you could add y dy to the other side. And then, to get all the y's on one side, you could multiply the equation by e to the y, right? Yes. So now we have separated the equation. And now we have to integrate. Some of you are looking at me like, do it for
Please.
You guys remember how to do integration by parts, right? Or tabular, if you prefer that method.
tabular.
Unfortunately.
I don't remember.
That's not that hard.
Josh Kim taught us integration by parts.
What's that?
Josh Kim taught us.
Oh, that was a senior teach
by
day?
parts, yeah.
Nice.
So we don't remember.
Let's see. For integration by parts, the integral of u dv equals uv minus integral of v du. That's the integration by parts formula. Now, I will tell you this right now. Anytime we have an integral where we have a polynomial function in there, that's a good thing. We don't have to actually do it that way. We can do it with tabular. If you forgot tabular, you take the polynomial part of the product, you differentiate, so derivative of x is 1, derivative of 1 is 0. You differentiate until this goes to 0. And then on the other side, you integrate. So we take the derivative of sine x, or I'm sorry, the integral of sine x, which is negative cosine x, and then negative sine x. And then if I recall, this gets added together, right? This product gets subtracted, and then just alternates. Okay? So then on the left-hand side, when you're done integrating, you should get negative x cosine x plus sine x. And then if you repeat...
What?
No.
You multiply these two, and you...
And you add them to the
And then it's like a positive... positive term, but it's x times negative cosine. Here you do the opposite of the product. So I guess it's kind of weird. You're not adding this with that and subtracting that. You're multiplying them first and then alternating signs, positive, negative.
Like a matrix.
Yeah. On the other side, let's see. y1, 0, e to the y, e to the y, e to the y, right? The first product is y e to the y, and then we subtract 1 times e to the y, and then we get plus c. And here, I'm good. Let's leave it. This is an implicit solution.
Oh, you can just do that?
Well, I mean,
That's what I wanted to do before, but
What do you know? Yeah, like what
you
is
said no.
Find y, solve y.
do you want us?
It's y and
Yeah, but y and e to the y, I see not a very good road ahead of us if we're going to try to isolate y.
I don't think I have enough room.
Okay. When does this end? 54?
Yes.
Okay, just enough time. Last thing we're going to talk about.
Okay.
An IVP. A special IVP.
Is that the beginning of calculus? No, like all the way to the beginning of the notebook.
dy dx equals y squared minus 4 with y of 0 equal to negative 2.
Is this a long exam?
Yes,
Okay.
I'm not going to lie and say it's short. It's going to take, no, not at all.
Oh, wow.
There's a lot of stuff that's, well, hopefully you see that there's going to be some work involved. When you separate variables, what do you get? Don't mess that up. dy over y squared minus 4 equals dx. I am a Simpsons fan. Yeah. How do we integrate dy over y squared minus 4?
Yeah. We have to separate the fraction.
Partial fractions, yes.
Whoa, we didn't learn that.
Yes, you did.
No, I
You
swear
took
we
calculus and pre-calculus. You learned partial fractions.
didn't. No, I
Yes, you did.
didn't.
I teach pre-calculus.
We did.
You do partial fractions in pre-calc, and you do it again in calc.
Wait.
So I know you know it, so I'm not going to review it at all.
Yeah.
ABC.
No, I'm just kidding. We'll review it.
Please.
We didn't like that.
All right. Is it clear?
There's a trick that Kuto.
This is ugly.
Kuto has a trick on how to do it.
You can't
All right.
do this.
So
Yeah, you cover up one.
the dy we're going to ignore.
But you can't use like inverse sine or inverse tangent or something.
No, I
You should.
This factors into y minus 2 and y plus 2.
I don't.
Do we need a review of how to set up partial fractions?
Yes, please. Thanks.
What's the shortcut?
I have no idea.
Don't worry about the shortcut. It's
Why?
not going to work all the time. I'm not going to bother. It's like you say, well, you have to set up the equation first. Then you're like, well, let's say y is 2, which makes it 0. Then what's the other value? And then you do it. Yeah, it's. All right, so here's what you're supposed to do. So I'll finish this and I'll review the setup for all the partial fractions you may encounter. Okay? Multiply by the LCD, which is y squared minus 4. You get the equation 1 equals a times y plus 2 plus b times y minus 2. And if you group the y's together, you get ay plus by. So I'm going to do a plus b times y. And then if you group the constants together, you just get 2a minus 2b. And then what you're supposed to do is compare coefficients. So on the left-hand side, there are 0 y's, right? Which means then that a plus b has to be 0. On the left-hand side, we have a constant value of 1, which means that this constant value has to be 1.
But how did you do that? Those last two things?
Compare, it's like balancing equations. How many y's do you see on the left?
None.
Here we have a plus b on the right. If they're supposed to be equations, then a plus b have to give you 0. Otherwise, this doesn't make any sense.
Okay.
You see what I mean?
Yeah.
And then on the left side, you have a constant of 1. So that means that the constants on the right have to equal 1. And now you solve the system. You can double the first equation, add everything up. You get 4a is 1, so a is a quarter. And then if a is the opposite of b, b is negative a quarter. You guys see how I did that, right? Okay. So then now I'm going to go back and actually finish, or at least get this going and set it up. So this becomes the integral of a was a quarter, so 1/4 over y minus 2 minus 1/4 over y plus 2. This is all dy. And that equals the integral of dx, which is just x plus c. To integrate 1/4 over y minus 2, you get 1/4 natural log of y minus 2 minus 1/4 natural log of y plus 2 equals x plus c. What's that? We're going to, yes. We're gonna find as much as we can here. So this becomes 1/4 natural log of y minus 2 over y plus 2. We could multiply by the 1/4. So we have 4x plus some other constant, where c is just double the original. C1 is double the original constant. We could exponentiate both sides, make each one the power of e, right? So then the e and the natural log cancel out. We get y minus 2 over y plus 2. And then now we're going to get a new constant. When you add exponents, that's the same as multiplying, right? So we have an e to the 4x. And then this e to the c1, I'm going to call c2.
This combination of so many things.
Isn't that plus or minus the absolute values?
What's that?
Isn't there a plus or minus? C2 equals plus or minus e to the C1 because of the absolute values. It got dropped.
No, because if you go back to the very first equation that we had, you can't make this side negative. Well, I guess you could. It's not going to end up mattering. Because, I mean, this constant will take care of that. Does that make sense? So if there is a plus or minus to be had, it will be determined by the constant. So that's why we don't need it. Okay. We're sort of out of time. I'm going to finish this problem tomorrow. It'll take 5 more minutes to finish the lesson, and the rest of the time will be yours to work on packet. Now, please get as far as you can in 2-2. You should be able to finish almost all of it. If there's partial fractions and you don't know how to do them, see if you can figure it out. If not, I will also review that with you guys tomorrow. Okay?
I mean,
Carolina and I both went on the I loved on it at like lesser clarity. I was gonna ask the teacher, but then I
In 2.1, question like, you know how we have to find, sometimes they're like, find equations by